so in this problem we're given a function f of x equals to negative 2x plus 5. This is a linear function. And we're asked to do three things here. Graph, find the intercepts, and find the zeros. Okay, this is something that we'll be asked to do for a lot of functions as we move forward. We'll do polynomial functions, exponentials. Very often we're interested in their graph, their intercepts, and zeros. Okay, it's nice to start with this one because the algebra for these is fairly quick and easy. You should already remember what the graph, right, of a linear function looks like. That is a line. There's typically two ways that we would get these graphed. One would be using this y-intercept and slope. So again, remember the slope is that coefficient of x there. So slope is negative 2. We often write it as a fraction, so we think of rise over run. And then we often call the b to be 5, but remember that would be the 0.05. That's the y-intercept. So with this point in the slope, we could graph. So again, we plot our point at 0, 5. And then from there, the slope says we go down 2 over 1. So down 2 over 1, do it a couple times maybe, and then we get a pretty good graph for our line. Okay. The second way we could do this, as most of the time it'll be up to you, is to find 2 points. 2 points determine a line, so that would be enough to get it graphed. And again, normally you would just, right, we're looking for 2 points. Most of the time you'll just pick an arbitrary x and then plug it into your function. So if I'll just say plug in 1. So if x is 1, again remember then y equals negative 2 times x, which is now 1, plus 5. Negative 2 plus 5 is 3. So that would be x equal to 1's partner. And then I guess I'll just take x equal to 2. So remember that's negative 2 times 2 plus 5. Negative 4 plus 5 is positive 1. So we get the ordered pair 2, 1. And you can see it would give you this 0.21, the 0.13, and obviously the same line there. Okay. For lines, that's how we'll graph. You could take slope and y-intercept, or slope on any point, or just plot 2 points. We go to other kinds of functions, we'll need other graphing techniques. Okay. Intercepts, again, remember intercepts are points where the graph crosses the axis. So if it's an x-intercept, it means it has to be a point along this x-axis. We can see our x-intercept here, that we'll find out here in a moment. But again, if it's on the x-axis, the x-intercept we're looking for, clearly it's going to be something comma 0. So this is the coordinate you get for free for the x-intercept. So for the x-intercepts, write this down here for part B. Again, you know for free that the y part is 0. So we're going to set the function. Remember, we're given it in the function notation, negative 2x plus 5. This is holding the value or the place for the y. So in our case, we know y equals 0. So we just substitute that in, solve. We just have to subtract the 5 over and divide by negative 2. And so 5 halves. Okay. Again, you have to let the y value be 0 and then solve for x to get the x-intercepts. For y-intercepts, again, that's a point where the graph crosses the y-axis. So it has to be somewhere along the y-axis. We can clearly see ours here. Okay. But again, if the point we're looking for is on the y-axis, we know the x-coordinate is 0. So it's just a matter of finding the second one. Okay. But again, if we're given this function, if we know x is 0, then we change x to 0. In this case, you get y equal to 5. Okay, so we did find one x-intercept, one y-intercept. For functions, there can only be one y-intercept by the vertical line test. X-intercepts, there could be more. Now, lines can only cross the x-axis at most once, but when we get more graphs, they might go up and down a few times. They could pass through the x-axis several times, so we might find several x-intercepts. And then finally find the zeros. Again, something we often want to do for functions. What you need to remember is a 0, when you're looking for the zeros, you need to find the x values. So again, we're going to be finding x's, in this case, that result in 0 outputs. Which again, if the output is 0, that means y is going to be 0. So they're going to match up nicely with x-intercepts. Okay. So again, if you're looking for zeros for this function, for any function, you're going to have to set the function equal to 0. You're going to find out when the output equals 0 and go back and figure out the x's. But again, that's obviously very similar to what we do for x-intercepts, so we subtract the 5 and divide. I will say that when we list zeros, we tend to just list those x values. We don't typically write them as points like we do up here for x-intercepts. Okay. Eventually, these can be a little bit different. Again, when you solve for zeros, you can see it's set up the same way. Sometimes, especially when we get to quadratics, when we start solving, we could come up with imaginary solutions. So those would not be on the graph because we're only graphing the real numbers. So when we start coming up with solutions like I, they would be a 0, but they would not be an x-intercept.